welcome to Unit 2, finally, everybody. So today let's go over this warm-up and then we'll get to it. We are looking at solving the system of equations for number 1. Of course, there's a few different ways we could do that. We could give them in a slope-intercept form and graph them, but it looks like algebraic is probably going to be the best way, and since this second one just has a minus x, and really we need to rearrange it anyway because it is in the opposite form, we're going to go ahead and multiply it by 4. So that way we end up with minus 4x, plus 8y equal to 28. And then we have the first equation we didn't manipulate yet, or we won't, 5. We're going to add these up, and when we do, we'll lose the x's. And then we'll have 8y plus 3y is 11y. Oops. Sorry, I hit the wrong color there. 11y. Not that it matters. But 28 plus 5 is 33. We divide by 11 on both sides. And y is 3. So now that we have y, we can use either of these two original equations to find what x is. And I'm going to say to use the second one. So that's going to be 2 times 3 minus x equal to 7. So that's 6 minus x equal to 7. We subtract 6 from both sides. And negative x is equal to 1. So x is equal to 1. So our solution set is in the order pair of 1, 3. Number 2 is also a system of equations, but we have to just come up with it ourselves. The sum of two numbers is 2, so that means that x plus y equals 2. And the first number is 14, so x is 14 less than the second number, so y minus 14. So that means that we already have one of them solved for x, so the easiest thing to do here is use substitution. So we're going to take y minus 14 and plug it in for x in the first equation. So y minus 14 plus y equal to 2. So that's 2y minus 14 equal to 2. We add 14 to both sides. And we now have 2y equal to 16. And we need to divide by 2 on both sides. So y is equal to 8. And now, since we have that second one solved for x, we might as well use it. So x is equal to 8 minus 14. And x is equal to a negative 6. So our ordered pair, if you want to write it that way, it's negative 6, 8. And there you go. The sum of those two numbers is 2, and the difference is 14. So today we're going to start to take a look at our next unit, which is quadratic functions. So we got a few vocab words to look at today, not a lot, but a few. So the quadratic function, quadratic term, is the first term in a quadratic function. The linear term is the one with just x, and the constant term is the number. Parabola is the graph that it forms. Axis of symmetry is the line that divides it perfectly in half. And we got vertex, which is the point at the very bottom of the parabola. Maximum value is what it would be if it opens down where the vertex is. That's the maximum value. And the opposite, if it opens up, the minimum value is the vertex there. And then, of course, quadratic equations, standard form for them, the root, which is the same thing as the solution, or an x-intercept, or a 0. And there we go. So our first problem, what we're going to do is just come up with our table of values that goes along with this. So we're just going to fill in some numbers in the table and come up with what the y values will be and then plot the points. So let's start with 0. It's the easiest one to always start with. So when we plug that in, 0 squared plus 3 times 0 minus 1. Of course, all those things with 0 we're going to cancel, and we're just left with minus 1. So our point is at 0, negative 1. Do the same thing, let's go with 1 here. So 1 squared plus 3 times 1 minus 1. So 1 squared, of course, is 1. But we also have this minus 1. Those two are going to cancel each other out. So we're left with just the 3 times 1, which is 3. So that's going to be 1, 3. And since we are graphing a parabola, we know we need to go both directions. So let's check and see if the 0 is our axis point, or our vertex point, sorry. So negative 1, we're going to check that. So negative 1 squared plus 3 times negative 1 minus 1. Again, the negative 1 squared is positive 1, and the 1 being subtracted will cancel it out. So it's 3 minus 1, or negative 3, or 3 times negative 1, sorry. So that's at negative 1, negative 3. So it looks like our vertex is somewhere in the middle there. Between 1 and negative 1? No. So we're up at 3 and negative 3, so that's not right. So let's keep looking. So negative 2, let's try that one. Negative 2 squared plus 3 times negative 2 minus 1. So that's going to be 4 plus negative 6 minus 1. So that's 4 minus 7 basically, or negative 3. So now we got the same y value out, so we're at the same level as we are with the point above. So negative 2, negative 3. So that means that our vertex point is somewhere between x equal to negative 1 and x equal to negative 2. Let's keep going though. Negative 3. So negative 3 squared is 9. 3 times the negative 3 is negative 9. So those two are just going to cancel each other out. And we're just left with negative 1. So negative 3, negative 1. So let's plot some of these points so we know what we're talking about here. So at 0, negative 1, down there. And then at 1, we're up at 3. At negative 1, we're down at negative 3. At negative 2, we're over at negative 3 as well. So that means, again, our vertex point is somewhere in between those 2 points. It doesn't tell us to find the vertex, though, so we're not really concerned about it, but we know that it needs to be somewhere in between there, but it doesn't matter that much. So you can kind of see the symmetry going on here, so we're going to go ahead and plot our next point without getting it on our table at negative 4, 3. So now we just connect our points. It's going to be something like that at the vertex. Again, we're just graphing it, but there we go. It's something along those lines. It's very close to that, if not that. The vertex is somewhere between negative 1 and negative 2, and it's likely right halfway in between at negative 1.5. So here is some info about the graph of a quadratic. So again, it is a parabola, and you just want to consider the graph there. So there are these different equations that happen. So the y-intercept is when x equals 0. That's true for every graph. And in that case, for a parabola, or a quadratic, the c, the constant term, the last one without an x in it, is going to be where your y-intercept is. So on that last problem, our y-intercept was at negative 1, which was at the very end of our equation was a minus 1. So we could have just used that and known immediately where our y-intercept was. And then the equation for the axis of symmetry and the x-coordinate for the vertex, they really use the same formula, the negative b over 2a. You just plug that into that and it'll get you that information, so you kind of know where the division is between your two halves of your parabola. So our next work is for you to work on.